Welcome back to Swedish Tech Blogger. I'm Deepak Kamboj, and in today's episode, we'll be tracing the fascinating evolution of artificial intelligence, from its early beginnings to the sophisticated generative AI models we see today. This journey through time will help us appreciate how far we've come and where we might be headed. AI's journey began in the mid-20th century with rule-based systems. These early systems relied on predefined rules and logical operations to perform tasks. Think of them as highly sophisticated calculators. While groundbreaking, these systems were limited by their rigidity. They could only perform tasks that were explicitly programmed into them, making them inflexible and unable to adapt to new situations. The real breakthrough in AI came with the advent of machine learning. Unlike rule-based systems, machine learning algorithms could learn from data. This shift allowed AI to move beyond rigid programming and start recognizing patterns and making predictions. For example, instead of programming a computer to recognize a cat in a picture, machine learning algorithms could be trained on thousands of cat images and learn to identify a cat on their own. The development of neural networks was another significant milestone in the evolution of AI. Neural networks are designed to mimic the way the human brain processes information. These networks consist of layers of interconnected nodes, or neurons, that process data and learn from it. The more layers a neural network has, the more complex patterns it can recognize. This led to the rise of deep learning, a subset of machine learning that uses multi-layered neural networks to process data and make decisions. Generative AI represents the next leap forward in this evolution. Unlike traditional AI, which focuses on recognizing patterns and making predictions, generative AI is about creation. Generative adversarial networks, GANs, and variational autoencoders, VAEs, are at the forefront of this revolution. GANs, introduced by Ian Goodfellow in 2014, consist of two neural networks in a creative duel, the generator and the discriminator. The generator creates new data, while the discriminator evaluates it. This feedback loop leads to increasingly realistic outputs. Variational autoencoders, or VAEs, work by encoding data into a latent space and then decoding it back into its original form. This process allows the model to generate new data that is similar to the original input. VAEs are particularly useful for tasks like image generation and data compression. Generative AI has a wide range of applications. In the world of art, AI-generated paintings and music are gaining recognition for their creativity and originality. In healthcare, generative AI is used to design new drugs and predict the structure of proteins. In entertainment, AI is being used to create realistic virtual characters and immersive gaming experiences. However, the rise of generative AI also raises important ethical and societal questions. As machines become more capable of creating content, we must consider issues related to authorship, intellectual property, and the potential for misuse. For example, deepfake technology, which uses generative AI to create realistic but fake videos, has raised concerns about misinformation and privacy. In this episode, we've traced the evolution of AI from its early beginnings to the sophisticated generative AI models we see today. We've explored the development of machine learning, neural networks, and the key technologies driving generative AI. Understanding this history helps us appreciate the incredible potential of generative AI and the challenges we must navigate. Stay tuned for more episodes of Swedish Tech Blogger, where we dive deeper into the world of generative AI. If you're enjoying this journey, subscribe, leave a review, and share it with others who are curious about the future of technology. Together, let's explore the endless possibilities of AI.